effective annual rate versus stated annual interest rate. So let's see what the difference is between the two. Stated annual interest rate is simple interest, and it's primarily used for quoting purposes. So when you walk into a bank and they have a big advertisement poster that says, we're going to pay you, 5% on your savings account, that rate is in terms of stated annual interest rate. On the other hand, effective annual rate compounds interest. And what it does is it measures the true or the effective rate that you would be earning on your account. Now, the best way to demonstrate the difference between the two is by looking at some examples. So the first example is as follows. There's a savings account that promises to pay 4% every 6 months. So therefore, when the bank has to quote this or make up their advertisement, what they'll do is they'll say, 4% every 6 months, so that would be twice a year. So therefore, the rate that they will quote is 8%. But then they would have to indicate how often that 8% is being compounded during the year. And as we saw here, it's being compounded on a semi-annual basis. So then, when you walk into the bank and you see 8% compounded semi-annually, what you need to do is you need to work backwards and say, that means they're paying 4% every 6 months. And that's just the way it works. So then the next question is, if they are paying 4% every 6 months, am I really making 8% over the year? Or am I making something else? Well, let's have a look. And that's where effective annual rate comes in. The way I labeled it is it's the true rate of return that you're making during the year. So let's do a scenario here. So here's today. This is when you walk into the bank, and let's assume you deposit $1. And if you want to know what the true effective rate is, we just need to find out what the dollar is worth at the end of the year. Because the difference between your initial dollar and the ending value at the end of the year would be your true return. So let's see what happened to our dollar. Well, in the first 6 months, we carried forward our dollar, plus we made an extra 4%. So by the end of the first 6 month period, our dollar is worth 1.04. But then in the second 6 month period, when they once again pay you 4%, now they're paying you 4% on the $4. And that is what compounding means. So in the second 6 month period, you're earning 4% on the 4 cents you earned in the first 6 month period. So then when you work this out, your dollar at the beginning of the year is now worth 1.0816 at the end of the year. Now, what portion of this is my return? Well, the dollar here, that's your initial principal, that's this, so that's not return. That's just your initial principal. So therefore, the difference is your true return or effective annual return. And notice with this simple framework, I don't even need a formula, right? Because I know I started with $1. So if my return is 0.0816 on $1, that works out to 8.16%. So you see, ladies and gentlemen, even though the bank was quoting 8% as their SAIR or stated annual interest rate, the true or effective rate of return you earned during that period was actually 8.16. Where did this extra 0.16 come from? The compounding. You could see it right here. You're earning 4% in the second 6 month period on the 4 cents you earned in the first 6 month period. And actually, 0.04 times 0.04, that's your 0.16 right there. Now, this is a really nice visual framework, right? And I used it here to demonstrate the dynamics of compounding. But on the exam, you're going to have to sort of get more to the point. So yes, it's important for you to know this in the background, but really this is the quicker way to arrive at that. And all the algebra is going to do is it's just going to condense this. So for example, instead of saying $1 compounded 4% in the first 6 months, 4% in the second 6 months, you could see that what I've done here is I've said, that 1.04 appears twice. So just the power of 2 is equal to this 1.086. And how did we get that? Well, it's just the $1. Bring forward our capital plus that 8.16%, which represents our effective annual rate. So therefore, here's what it says. My $1 growing at 4% compounded twice covers a period of a year, and that should be equal to my $1 growing at the effective annual rate, but just compounded once, and that too covers a year. Now in this case, why are we compounding it just once? Because the A stands for annual. It's already in annual format. So all I got to do is I got to compound the annual rate just once in order to cover a year as well. Now since this term covers a year and this term covers a year, they are equal. And that's how you solve for EAR. So if you just look at this framework right there, again, it's just an equation with one variable. So you just solve for EAR, you get 8.16%. So the same as that. Now we're going to do a few more examples because this concept of finding effective annual rate from a quoted rate is super important, and not just for the CFA program, but I mean anyone who's got a credit card statement, you'll see that there's a difference between the rate that's quoted and the effective rate that's actually costing or earning during the year. And the difference between the two is because of that compounding effect. So let's look at a second example. Suppose now a different bank is offering to pay 2% every quarter. So the first thing is, well, how would they quote this? Well, they'll say, 2% every quarter, that's 4 times a year. So on an annualized basis, that's 8%. But then the bank would have to tell you how often that 8% is being compounded. And then what we do is we work backwards. So when we walk into the bank, we see this being advertised, 8% compounded quarterly. So then we work backwards and say, oh, that means the bank is paying 2% every quarter. And then you ask yourself, well, if that's the case, am I really making 8 or am I making something else? And that's where effective annual rate comes in. Now, here's the same framework as we used here, but now we're doing it on a quarterly basis. So let me show you the process. Now, I'm a visual person. So what I like to do is I like to picture myself depositing $1. And I just want to know what happened to my dollar over the year. Now, there's 2 ways to go about it. In the first case, I could be making 2% on my dollar 4 times during the year. And that's where I would compound 4 times. And if you want to see this, this expression in full, here's what it's saying. My initial dollar is being brought forward. That's what the 1 plus says. It says bring forward your initial dollar and earn 2%. Now, how often does that occur? 4 times. Alternatively, I can walk into the bank with $1 and just invest it at the effective annual rate. And since it's annual, I would only have to compound it once. And this too would tell me what my dollar would be worth at the end of the year. So once, the reasoning brings us here, algebra takes over. And what I mean by that is you have one equation with one variable. So you solve for EAR. In this case, it's 8.24%. Third example. Suppose that the bank promises to pay you 0.667% per month. So how would they quote this? They'll say 0.667% per month over 12 months. So that works out to 8%. But then again, the bank has to tell you how often it's being compounded, and they'll tell you compounded monthly. Once again, you walk into the bank, you see this, but then you work backwards. You say, oh, 8% compounded monthly. That means the bank is going to be paying me 0.667% each month for 12 months. And then you ask yourself again, am I really going to be making 8%? Or is my true effective return going to be something else? So that's our segue to calculate EAR. Same process as before, ladies and gentlemen. Same process as before. Imagine yourself depositing $1 at this bank. And there's two alternative ways to explain what's going to happen to your dollar. In the first explanation, here it is. I bring forward my dollar, and each month I'm going to be making 0.667%. Now notice when we're doing algebra, we like to convert from percentage to decimal. That's why you see me using 0.00667. But in any case, here's my dollar growing at the monthly rate. And how often is this happening during the year? It's happening 12 times. So you see how we're using logic to arrive at the framework that's being used. Alternatively, I can walk into the bank with my $1, and again, I would carry forward my dollar because I don't want to lose my dollar. I want to get my dollar back and earn a return on it. In this case, the return would be the effective annual rate, and because it's the annual rate, I would only have to compound it once in order to cover a period of a year. So then, once we use the logic to arrive here, at this point, algebra just takes over. And what I mean by that is, you have one equation, one variable, you just solve. And in this case, it's 8.30. Now, the last form of compounding, and this is the ultimate form of compounding because it's continuous. So in this example, we're looking at a savings account that pays 8% compounded continuously. So for quoting purposes, it would be quoted as 8% compounded continuously. But then again, you got to ask yourself, am I really going to be making 8%, or is my true effective return going to be something different? Now, when we're using continuous compounding, the structure changes a bit. So we're going to be using this framework. So the variables in this framework are as follows. So the X here, that's the return with continuous compounding. And then the R is the discrete return. In other words, it's the equivalent rate, but without the compounding. So then all we have to do is plug in 0.08. That is our SARE, and solve for the R, which would be our proxy for the effective annual rate. And on our website, I show a tutorial of how to use your calculator in order to navigate your way through these exponential functions. So when you plug in 0.08 and hit the E button over there, you get the following number. And of course, then what we do is we just cross out the ones, and then the discrete return or the effective annual return would be this. So this is in decimal form, expressed as a percentage would be 8.329%. So even though the bank is saying that they pay 8% compounded continuously, which is the maximum frequency for compounding, that works out to an annual effective return of 8.329%. So now let's look at a summary of all the examples that we did. Now, if you recall, for each of the examples, we held the SARE constant at 8%, so stated annual interest rate. However, as the compounding frequency increased, the effective annual rate increased as well. So remember, we started with semi-annual. So it was 8% semi-annual, 8% quarterly, 8% monthly, 8% continuously. But then when you took into account the compounding effect, on a semi-annual basis, the effective annual rate was 8.16, and then it rose to 8.24 with quarterly compounding. Monthly, it rose to 8.30. Now, why is it increasing? Because interest is being earned on interest more often. And so that accumulates your ending value and therefore results in a higher effective annual rate. And finally, the ultimate form of compounding, so this is the maximum number of compounding frequency you can have, which is continuous compounding, the effective annual rate equal to 8.329%. And as I indicated before, the more often that interest is computed, in other words, as the compounding frequency increases, the faster that the accrued earnings will grow, and therefore explaining why EAR is increasing.